Chapter 4.2, exercises 1 through 18. Section 4.2 in our book has to do with finding trigonometric functions using trigonometric functions of acute angles. And so I'm going to go right to the exercise set and just kind of flip through these examples quickly. In exercise 1 through 8, find the values of all 6 trigonometric functions of the angle theta. So you have a triangle with an angle theta in the lower left corner of the triangle. We have sides with lengths 3, 4, and 5 respectively. As far as what's important to know about the sides of this triangle is you have 3 sides that we need to know. We need to know which side is our opposite side. We need to know which side is our adjacent side to our angle. And finally, we need to know our hypotenuse. And trigonometric ratios are such that if we know any 2 of the 3 sides, we can find at least 2 trigonometric ratios based on those 2 of 3 sides of a right triangle. What I look for is where theta is. And so we have theta in the lower left corner. So to find the opposite, we can go just opposite side of the triangle from that angle measure, theta. And and this is common, we see that's a Greek letter theta, usually referring to angle measure. And so this side opposite this theta is called our opposite side. I'm just going to abbreviate OPP. And then our longest side is going to be our hypotenuse. So I'll say HYP, our hypotenuse, is equal to 5. And finally, our adjacent, which is just not from the theta, one side is going to be opposite, the other side is going to be called the adjacent side. So I'll abbreviate that bottom side as ADJ. And then finding the trigonometric functions or ratios is really simply a matter of remembering which of these ratios go together in what order. One thing that's commonly used for trigonometric ratios that I don't especially like is this acronym, this device, SOHCAHTOA. And if this SOHCAHTOA works for you, wonderful. Use it. Never lose it. I like another mnemonic device, which is maybe a slightly bit more edgy, which is this one. Some old hippie. And for that represents sine equals, and I'll just put sine theta, that's another bugaboo. Sine theta equals opposite over hypotenuse. Okay, and the next 3 words, cot, another hippie, and for that, we have the cosine of theta is equal to, another would represent adjacent over hypotenuse. And then the last sentence we use is tripping on acid. And tripping on acid refers to the tangent of theta, TAN for short, is equal to the opposite over adjacent. ADJ, let me go ahead. So let's go ahead and apply this device. You can see that this really mirrors SOHCAHTOA, doesn't it? It's just maybe, I don't know, just what I prefer. So the first thing we're going to look at for the 6 trigonometric functions or ratios is we're going to look for sine. So sine, and that's going to be sine theta, is going to be equal to our opposite over hypotenuse, and our opposite side is going to be 4 over hypotenuse, which is 5. Now, the reciprocal ratio to sine is cosecant, which is CSC, and cosecant theta is the reciprocal of sine, so that's going to be hypotenuse over opposite. So up here we have sine theta equals 4/5, and cosecant theta equals what? 5/4. Just turn that thing upside down. Next, we have cosine theta. And remember, from the mnemonic device, it's going to be adjacent over hypotenuse, so our adjacent side is 3, and our hypotenuse is 5, and our reciprocal ratio to cosine is called secant. It's abbreviated SEC. So secant theta is going to be the reciprocal of cosine theta, which is going to be hypotenuse over adjacent. And so coming up here, adjacent to this cosine theta, we have secant theta is equal to 5/3. And finally, our tangent theta is equal to our opposite over adjacent, which is going to be 4. Opposite side is 4, our adjacent side is 3. And similarly to determining the cosecant and secant, the reciprocal of tangent theta would be cotangent theta, abbreviated COT. So cotangent theta is going to be adjacent over opposite, just the reciprocal of the tangent. So up here we have cotangent theta is equal to, instead of 4/3, we have 3/4. And that's going to be our answers rather, to problem number 1. Next, let's go to problem 3. We have this one here. Now, we have a little bit different challenges with this problem in that a lot of people have trouble if your angle is not in the same place relative to each triangle. For example, if we look back to problem 1, we saw in the lower left-hand corner the angle theta. Here, for problem 3, in the upper left-hand corner is where angle theta is located. But it's the same principle. We go ahead and take theta and draw an arrow opposite from theta and get 12. So 12 is our opposite side. Adjacent is going to be 5. And the hypotenuse, which is the longest side, is going to be 13. So our sine theta is going to be equal to, remember, some old hippie, opposite over hypotenuse. So our opposite is 12, and our hypotenuse is 13, and consequently our cosecant, which is the reciprocal of sine, is going to be equal to 13 over 12. You might notice that sine and cosine have to be less than or equal to 1. Well, the reciprocals, cosecant theta and secant theta, are going to have to be greater than or equal to 1. Next, cosine theta is going to be equal to adjacent over hypotenuse, and our adjacent side is 5, and our hypotenuse again is 13. And our secant theta is the reciprocal of cosine theta, which is going to be 13/5. And mathematically, if you work this out, we would get 2.6. Tangent theta is equal to opposite over adjacent. Our opposite side is 12. Our adjacent side is 5. And cotangent is reciprocal of tangent. So cotangent theta equals 5/12. Tangent also is like, you have opposite over adjacent. It's really what rise over run is, right? The rise, we rise from the base of the triangle 12, and the run, we move over 5. So that's one way I like to look at tangent sometimes. Helps to connect to algebra. Next, problem 5. We have this triangle. In this case, we have our theta over here in the lower right corner, but it's the same principle. We draw an arrow opposite. So 7 is our opposite side, and our adjacent side is down below, which is 11, and our hypotenuse is always our longest side, which we do what? We don't yet know, so we have to find this out. Before that, we have the most famous formula in mathematics at our disposal, and that is going to be the Pythagorean Theorem, which is a squared plus b squared equals c squared. And for that, we have 7 squared plus, and b is going to be our 11, so 7 squared plus 11 squared equals c squared. So 7 squared is 49, and 11 squared is 121 equals c squared. So 170 is equal to c squared. So taking the square roots of both sides of this equation, we have c is equal to square root of 170. And if you've solved quadratic equations, we're using the square root method before, you might be familiar with a plus or minus. You take the square root, solve a quadratic equation, use the square root method, it's plus or minus. But in this case, we know that distance is always positive, so c, side c, our hypotenuse, is equal to square root of 170. And so we're going to label that our hypotenuse. And now we can get to work on finding the ratios. And for those, we have sine theta is equal to our opposite side, which is 7, over hypotenuse, which is square root of 170. And then we have our reciprocal ratio, which is cosecant. That's going to be square root of 170 over 7. Next, cosine theta is going to be our adjacent side, which is 11, over our hypotenuse, which is again square root of 170, and our secant, which is reciprocal of cosine secant theta, equals square root of 170 over 11. And the last one we're going to look at is tangent. So tangent theta, it's going to be our opposite over our adjacent, which in this case is going to be opposite side is 7, adjacent side is 11, so 7/11 is our tangent theta. And our reciprocal to our tangent is our cotangent, so cotangent theta is 11/7. And then we can box in these answers as correct. All right, next on our problem 7, we have again two sides. We have our opposite side down below, which is 8. Is that our opposite side? No, it's not, right? Our opposite side is our question mark. And our adjacent side down below is 8. And our hypotenuse is 11, which I abbreviate HYP. Again, we use the most famous equation in mathematics. It's good to have it around. Now, in this case, we have what C is. We have the longest side, which is 11. So C squared is 11 squared. And we have the adjacent side, which is 8 squared. But we do not have that other side, which is A. So we have A squared plus 8 squared. What is 8 squared? Well, 8 squared is 64. Equals 11 squared. 11 squared is 121. So A squared is going to be equal to 121 minus 64. I'm going to come bring it down like this. And for that, we're going to have, let's see, that's going to be 36, which is lower than 100, plus 21. 36 plus 21 is going to be 57. Is that right? 21 plus 36, 57. So 57. So we'd say the square root of both sides, A is going to be equal to the square root of 57. So let's go ahead and label this opposite side square root of 57. Here we go. Okay, so we use the same things we've used in the past. We have our sine theta equals our opposite, which is square root of 57, over our hypotenuse, which is 11. We have our cosecant theta, which is the reciprocal of sine, which is going to be 11 over square root of 57. Next, we have cosine theta. That's going to be our adjacent, and our adjacent side is going to be 8. And our hypotenuse is going to be square root of 57. Our secant theta is going to be our reciprocal of cosine, so that's going to be square root of 57 over, and then we have tangent theta is our opposite over our adjacent, and our opposite we discovered to be square root of 57, and our adjacent is 8. And cotangent theta is reciprocal of tangent, so cotangent theta is going to be 8 over square root of 57. So we can box in these answers as correct. Okay, next odd number problem, 9. And we're talking about a new set here. In exercise 9 through 18, assume that theta is an acute angle in a right triangle satisfying the given conditions. Evaluate the remaining trigonometric functions. So in this case, we have sine theta equals 3, over 7. And sine theta is going to be, the sine is going to be equal to our opposite over our hypotenuse. And so what we're going to do is use these lengths to draw right triangles. And some people just like to draw them any old way. I like to make them, these triangles, if I can, as accurate as reasonably possible. And so your hypotenuse is 7 and your opposite is 3. And so I'm just going to go ahead and draw what is going to be an opposite of 3. So 3 equals our opposite. And our hypotenuse we're going to have is 7. And so that's going to come from right up here. So I draw this down in this direction. And so I'm going to say hypotenuse is equal to 7. And then I finish the triangle by just connecting what's left. And there we have our triangle, and theta is going to go right in this lower left corner. And then to find the trigonometric ratios, all 6, we're going to need to have this bottom side, which is our opposite, which is our adjacent side. And to figure that out, we would say, again, a squared plus b squared equals c squared. We would have a squared, which we do not know yet, plus 3 squared equals c squared, which is going to be 7 squared, we will call that. So a squared plus 9 equals 4. 7 squared is 49. And so subtracting from both sides of this equation, we have a squared is equal to 49 minus 9, or 40. And taking the square root of both sides, we have square root of a squared is a equals square root of 40. Now, square root of 40 can be rewritten as 2 times the square root of 10. Why is that? Because we can rewrite square root of 40 as square root of 4 times square root of 10. And that square root of 4 becomes 2, and we have square root of 10 left. So that's going to be our adjacent side, 2 square root of 10. And now to find our trigonometric ratios, we have sine theta, which we already know is 3/7. And our cosecant theta is going to be equal to a reciprocal of our sine, which is 7/3. So we could have already found the cosecant without going through this process of finding the missing side. Cosine theta is equal to adjacent over hypotenuse, which is going to be 2 square root of 10 over 7. And secant theta is going to be a reciprocal of cosine theta, which is 7 over 2 square root of 10. And then finally we have tangent theta, which is our opposite over adjacent. Our opposite side is 3, and our adjacent side, again, is 2 square root of 10. And then our cotangent theta is a reciprocal of tangent theta, so we're going to have 2 square root of 10 over 3. And so there we have our ratios. In addition to the sine, which we already had, we figured out these other 5 trigonometric ratios. Next on our problem, which is 11, we have cosine theta equals 5/11. So again, I'm going to say 5 is going to be our adjacent side, and 11 is going to be our hypotenuse, and then set about making what we hope is a reasonable drawing of that. And so if we draw a triangle with adjacent side 5, I'm going to draw a horizontal line segment, and I'm going to label that length as 5 equals adjacent. Next, we're given a hypotenuse of 11, so I'm going to come up here and draw this line segment, not straight looking very much, but that's a hypotenuse of 11. And then we're going to finish out this triangle, leave a squared symbol at the bottom. So our opposite side is going to be equal to, well, again, same thing we did in the past. We have a squared plus b squared equals c squared. So we have a squared, which we do not know what a is, plus we say b is going to be our adjacent side, so 5 squared equals 11 squared. So we have a squared equals 25. Let me say this, a squared plus 25 is equal to 121. So to solve for a squared, if we subtract 25 from both sides of this equation, we have a squared equals 121 minus 25, which equals 96. Okay. So for this one, we're going to have a is equal to square root of 96. Now, 96, to simplify 96, we can rewrite 96 as square root of 16 times square root of 6. At square root of 16, we can simplify to 4 times square root of 6. So that's going to be our opposite side, 4 square root of 6. So our sine, theta, is going to be equal to our opposite side, which is 4 square root of 6, over hypotenuse, which is 11, and our cosecant theta, which is our reciprocal of sine, is going to be 11 over 4 square root of 6. Our cosine theta is going to be equal to our adjacent over hypotenuse, which is going to be 5/11ths, and our secant theta is our reciprocal over cosine, which is 11/5ths. The tangent theta is going to be equal to our opposite, which is 4 square root of 6 over our adjacent side, which is 5. And finally, our cotangent theta is going to be equal to 5 over 4 square root of 6. And that would be our answers are 6 standard basic trigonometric ratios. Next, odd number problem, which is 13. We have the tangent theta is equal to 5 over 9. And so for that, we have 5 as our opposite side, and our adjacent side, since tangent is opposite over adjacent, is 9. So we have simply to draw our triangle, and I'm going to put opposite is 5, so that's this little vertical line segment. I'm going to say opposite equals 5, and our adjacent is 9, so I'm going to come over here, draw a horizontal line segment. I'm going to say adjacent equals 9, and then just draw in our hypotenuse like this, and we have a right angle symbol right here and a theta symbol right here. I'm sure I did this right. Yeah, on 11 I sort of forgot, didn't I, to put the theta symbol here? There, I'm coming back and putting it, there we go. Okay, now we need to find the hypotenuse. So our hypotenuse we find by taking, again, a squared plus b squared equals c squared, which is going to be 5 squared plus 9 squared equals c squared, which is 25 plus 81 equals c squared. And 25 plus 81, that's going to be 106 equals c squared. So c is going to be equal to the square root of 106. So just going ahead and working this out, we have hypotenuse equals square root of 106. And then we have our sine theta is equal to our opposite side, which is 5, over our hypotenuse, which is square root of 106. Our reciprocal of our sine ratio is our cosecant theta, and that's going to be square root of 106 over 5. Now for cosine theta, that's going to be our adjacent, which is 9, over our hypotenuse, which is square root of 106. And our secant is going to be a reciprocal of cosine, which is going to be now square root of 106. And then we have, it's going to be over our adjacent side, which is 9. And tangent theta, we already had, right, is 5/9. And cotangent theta is the reciprocal of tangent theta, so that's going to be 9 over 5, which decimalized rounds off to 1.8. Anyway, I'm going to box in these answers as our correct answers, and then resume, this time with problem number 15. Here we have the cotangent of theta equals 11 over 3. And again, cotangent is not going to be adjacent over, it's not going to be opposite over adjacent, it's going to be adjacent over opposite. So our adjacent side is going to be this 11, and our opposite side is going to be this 3. And so for that, in just drawing the triangle, we can make a relatively short line segment here. Is opposite equals 3, and our adjacent is going to be our 11. So here we draw a horizontal line segment to the left, which is adjacent is equal to 11, and then we draw a line segment connecting the corners, and we have a little square symbol recognizing a right angle. We'll put the little theta down here in the lower left corner. And remember at the beginning when I mentioned that there are different orientations that give people trouble? The good thing about making your own drawings is you can orient these triangles as you wish. In this case, I've oriented them with the theta in the lower left corner. Well, again, for this one, we have a squared plus b squared equals c squared. And for that, we have 3 squared, which is going to be a, plus b squared, that's going to be 11 squared, equals c squared. That's going to, 3 squared is 9, 11 squared is 121, equals c squared. And adding 9 and 121, we have 130 is equal to c squared. And then, taking the square root of both sides of this equation, we have c is equal to square root of 130. And I think that's going to be as simple a radical form as we're going to make this. So we're going to have our sine theta is equal to our opposite, this is 3, over our hypotenuse. And our hypotenuse, which I have yet to draw in, the triangle, is square root of 130. In a practical basis, how big is square root of 130? Well, or how large? Well, square root of 121 is 11, and square root of 144 is 12. So square root of 130 is going to be somewhere between 11 and 12. And cosecant theta is equal to the reciprocal of sine theta, which is square root of 130 over 3. Next, cosine theta is equal to our adjacent side, which is 11, over our hypotenuse, which is square root of 130. And the reciprocal of cosine theta is secant theta, and that's equal to square root of 130 over 11. So hypotenuse over adjacent, that's what secant is. And then tangent theta is equal to opposite over adjacent, so that's 3/11. And we were already given cotangent to begin with, but just to round off, to complete the list here, we'll have cotangent theta is equal to 11 over 3. So box in these answers as correct. Okay, problem number 17, which is our last problem we're going to be looking in this set, the odd number problem. We have the cosecant theta is equal to 23 over 9. And so our cosecant is going to be our hypotenuse over, now cosecant is going to be the reciprocal of sine, so 9 is going to be our opposite side. So now we can draw our triangle. I'm going to draw a little opposite side of 9. right here, vertical. So opposite equals 9. And our hypotenuse is 23. So I'm going to bring my hypotenuse like this. So hypotenuse equals 23. And completing the triangle, our adjacent side is the one that we don't know. Well, again, a squared plus b squared equals c squared. We have, in this case, we'll say we don't know what a squared is. We'll say a squared equals 9 squared plus 23 squared. And so for that, we'll have a squared what do we have to do, guys? I kind of got it wrong, don't I? Let me just rewrite this. A squared plus 9 squared equals 23 squared. So that's going to be a squared plus, and 9 squared is 81, equals 23 squared. Well, 23 times 23, let's get that down. 3 times 3 is 9. 3 times 2 is 6. Okay, and then for this one here, 2 times 3 is 6, and 2 times 2 is 4. So we're going to get 9, 12, 5, so 529. So a squared is going to be equal to 529 minus 81. And that's going to be, we'll just put this out, minus 81. We get 8 here, and 52 minus 8 is going to be, what is it, 4? Is that right? 52 minus 8? I think that's right. And then as far as divisibility, well, we know that 448 is divisible by 2 to be 224. And 224 divided by 2 equals 112. 112 divided by 2 equals 54, is it? No, 56. And 56 divided by 2 equals 28. And so we have, just kind of reverse factoring, we'll have 2 times 2 times 2 times 2 times 28 will equal 448. So we have 2 times 2 times 2 times 2 is going to be 16 times 28. So that's going to be a squared. And so a is going to be equal to square root of 16 times square root of 28. And that's going to be equal to, square root of 16 is 4. And so we have 4 square root of 28. So that's going to be our adjacent side, 4 square root of 28 in simplest radical form. So next, just kind of assembling what we need here, we have sine theta is equal to our opposite side, which is 9, over our hypotenuse, which is 23. We have cosecant theta, which we were given, weren't we? It's going to be 23/9. Our cosine theta is going to be equal to our adjacent, which is going to be 4 square root of 28 over, let me see, that's not tremendously legible, 28, that's a little more legible, over our hypotenuse, which is 23. Our secant theta is going to be equal to 23, which is our hypotenuse, over our adjacent, which is 4 square root of 28. And now our tangent theta is going to be equal to our opposite, which is 9, over our adjacent, which is 4 square root of 28. And our cotangent theta is equal to the reciprocal of tangent theta, which is going to be 4 square root of 28 over 9. So there we have all of our 6 trigonometric ratios after finding the other 5. Good luck on the even number problems as a demonstration of your learning, and thank you for viewing.